GMS has unparalleled tools for working with flow observations. It is the only software on the market that can link GIS features to MODFLOW computed flows. A flow observation is a measurement of the amount of water exchanged between a head-dependent boundary condition and an aquifer. For example, a river may have multiple gauging stations so that the gain or loss between the river and the groundwater system can be measured. Flow observations in GMS rely on the conceptual model approach. Here is an example MODFLOW model created using the conceptual model approach. We created this model using GIS-like features of points, arcs, and polygons to represent our boundary conditions. In this model, we have specified head boundaries that correspond to a river on the south and east of the model. And we have used drains to model ephemeral streams. We have also modeled a spring using a drain, and we have two wells. We can see the exchange between the aquifer and one of the specified head arcs by selecting the arc and viewing the computed flow as shown in the status bar. Notice that the flow is negative. This means that the water is leaving the aquifer and entering the river. If we select multiple specified head arcs, then we can see the net computed flow from all of the selected arcs. Similarly, we can see the effect of all of the drains on the model by selecting the arcs. GMS is the only software that links GIS features to MODFLOW computed flows. If we have field data measuring the stream gain or loss, then we can add that as input to the MODFLOW model as an observed flow. We can turn on flow observations by bringing up the coverage setup dialog and turning on the observed flow option. Now we can assign an observed flow to our boundary conditions. We will double click on the drain arc and assign an observed flow. Notice that an observation target appears next to the drain arc. Calibration targets indicate the amount of error between the model computed value and the observed value. The target is green when the amount of error is within an acceptable tolerance. Yellow indicates that the error is greater than the acceptable tolerance, while a red target shows that the error is greater than 200% of the acceptable tolerance. Now we will assign observed flows to the other drain arcs. The next time we run MODFLOW, this flow observation will be included as part of the inputs, and it will also be included in the residual error computed by MODFLOW. Looking at the properties for our MODFLOW solution, we can see the error associated with the flow observations. In addition to arcs, flow observations can be assigned to points, polygons, and arc groups. An arc group is created by selecting the arcs and then using the group command. Once the arc group is created, we can assign the observed flow. Flow observations are also used by PEST to adjust model parameters. We will run the same model and allow PEST to adjust the drain conductance to calibrate the observed flows. Notice that the calibration targets have essentially no error, as PEST has adjusted the drain conductance. We can also enter flow observations for transient models. We turn on the Transient Observed Flow option in the Coverage Setup dialog. We can enter our transient observed data in date-time format. Now that we have entered our flow observations, we will run MODFLOW. We can also view a plot of the computed flow associated with the boundary condition over time. The green line shows the computed flow at the MODFLOW output times. Targets are drawn on the plot showing the match between the computed and the observed data. We can also import flow observation data from text files. We do this by using the text import wizard. After the data is imported, we just need to turn on the Observe Flow option and assign the interval. We will now run MODFLOW again to get computed values at our observation times. GMS makes working with flow observations simple. These tools help us create more accurate MODFLOW models